Welcome to Brain Vision.
Hello and welcome. We are looking at Chapter 8, Section 1. This is Problem 9. So we're asked to determine whether points lie on a straight line. These are 3D points, which complicates things a little bit. So there's lots of different approaches. About the one we're going to take, we're not going to make too many assumptions about what you already know. So if you have 3 points, if they lie on the same line, then if you take this distance, add it to this distance, you're going to get the same overall distance as if you just measured the total length between all 3. So that's the approach we're going to take here, because if they aren't collinear, then you basically have a triangle where, say, this distance plus this distance would not add to this distance. It'd actually be further because you're kind of going out of the way. So what we're going to find is we're going to find the distance for each of these, between each of these points, and then we're going to just do a little addition problem. So the distance from A to B, that's what we're going to start with. Right, so this is square root, and as long as you stay consistent, it won't matter if you do 2 minus 3 or 3 minus 2, so I'm just going to do it left to right. So I'm going to do 2 minus 3. This will be 4 minus 7. And then 2 minus negative 2. So that's going to, well, let's do this down here. That's going to be negative 1 squared is 1. Negative 3 squared is 9. And 2 plus 2 is 4 squared is 16. So the distance from A to B is root 26. Right? So let's do the same thing for B to C. So that would be 3 minus 1 squared plus 7 minus 3 squared, and then negative 2 minus 3 squared. So simplifying that, we have 2 squared is 4, 4 squared is 16, and then negative 5 squared is 25. So this would add up to square root of 45. Lastly, AC. This would be 2 minus 1 squared, then 4 minus 3 squared, and then 2 minus 3 squared. So we have square root of 1 plus 1, and then this will be plus 1, or root 3. So if we take the 2 shorter ones and add them together, root 26 plus root 3, the question is, does that equal root 45? We can use a calculator to verify this. Remember, root 26 plus root 3 does not equal root 29. So root 26 plus root 3, left-hand side, I got approximately 6.831. And for the right-hand side, root 45, I got about 6.708. So for part A here, you can say confidently no. All right, now on to part B, same process. So we need to find the length from D to E. So that'd be 0 minus 1 squared plus -5 minus -2 squared plus 5 minus 4 squared. All right, that would be 1. -5 plus 2 is -3, so that'd be plus 9 plus 1. That would be root 10. All right, next one, df. Zero minus 3 squared, just the two x coordinates, the difference of the x coordinates. -5 minus 4 squared. And then 5 minus 2 squared. So this would be the square root of 9. -5 minus 4 should be -9 squared would be 81. And then 3 squared again would be another 9. So this would be the square root of 18 plus 81 should be square root of 99. Yes, okay. And then lastly, EF. Right, so same calculation using the distance formula. All right. 1 minus 3 is -2 squared is 4. That'd be -6 squared is 36. 2 squared is 4. So this would be the square root of 44. So if we add up the two smaller sides, the question is, by the same logic we used on the previous page there, is this equivalent? So if we punch this into a calculator, it's one way to check. So this right-hand side is approximately 9.796, and the right-hand side I got 9.950. All right, so let's double check real quick. Oh, I see what I did here. So you probably saw this a long time ago, but this is square root of 10. It should be square root of 11. 9 plus 1 plus 1 is 11. So if I fix that, this actually does work out. I thought it was supposed to. All right, so this is, let me erase that to make it more clear. So then it works out to 9.950. And if you look at the full decimal, they do equal. So for part B, yes, these are collinear because the two smaller segments add up to be the same length as the longer segment. All right, we are done.